welcome to this explainer. Today, we are completely demystifying how code actually runs. And it's fascinating because it turns out you absolutely do not need to be some sort of math genius to start programming. It's really just about applying basic logic and getting comfortable with a few structured tools.
So, let's start by totally dropping your defenses. It's actually a huge relief to look at the prerequisites here. You do not need to know any advanced math beyond primary school arithmetic. You need zero AI knowledge. And honestly, you don't need to know a single line of programming syntax yet. No variables, no loops, no functions. We're starting from absolute zero, and that's exactly where you want to be.
Okay, let's take a quick look at our roadmap for today. We'll be covering the language of computers, a really helpful kitchen chef analogy, your core coding toolkit, some hands-on terminal and Python practice, and we'll wrap up with debugging like a pro.
Kicking things off with Section 1, the language of computers. Why do we even need programming languages in the first place?
Well, this highlights the core disconnect right out of the gate. Hardware and humans just do not speak the same language. Computers literally only understand electronic pulses, which we represent as binary machine code, just zeros and ones. In trying to write raw machine code, it is impossibly slow and a total nightmare for humans to get right. So we need a bridge. That bridge is Python. It's a human-readable programming language that acts as our translator, letting us write instructions that basically read like simplified English.
Moving right along to Section 2, the kitchen chef analogy. Let's make sense of this whole software system.
If we think about this process like baking cookies, the whole thing suddenly clicks. First, you have a recipe with numbered sequential steps, right? In software, that's your .py Python file. You hand that recipe over to a diligent assistant chef who follows your instructions literally, exactly as written, without making a single assumption. That chef is the Python interpreter. And finally, the chef uses the kitchen hardware to actually bake the cookies. That kitchen hardware represents your computer's actual physical CPU.
But what happens when things inevitably go wrong in the kitchen? Well, if you write a recipe with completely broken grammar, the chef simply can't read it. That's what we call a syntax error. But what if your grammar is perfect, yet you ask the chef to do something literally physically impossible, like, say, mix 1 cup of screwdrivers or divide by 0? The chef just stops immediately and shouts for help. That right there is a runtime error.
All right, Section 3, your core coding toolkit. Let's look at the actual tools you need to write your own recipes.
So what's really cool about Python is that it's considered a high-level language. Created way back in 1991 by Guido van Rossum, that term high-level simply means it was designed specifically for us, humans, to read and write easily. It completely hides all those complex, messy electrical details happening inside the CPU's memory chips, allowing you to just focus on pure logic using plain text. Next up in your toolkit is the terminal, which you might also hear called the command line. Now, I know it might look a bit intimidating at first glance, like something out of a hacker movie, but it's actually just a fast, super precise text-based window. You use it to type commands directly to your computer's operating system. Because here's the thing, relying solely on pointing and clicking with a mouse actually limits you. It prevents you from automating repetitive tasks. The terminal empowers you with exact, repeatable precision.
And the glue tying your text to the hardware is the Python interpreter. Think back to our cooking analogy for a second. This is the digital version of our diligent assistant chef. It's the software that runs your Python instructions line by line. It validates your text and automatically handles all those microscopic translation details so the physical computer hardware can actually execute your commands.
Which brings us to Section 4, Terminal and Python Practice. Time to put these tools into action. Okay, this is basically your essential terminal cheat sheet. You can actually navigate your entire computer completely through text using just these commands. PWD stands for Print Working Directory, and it shows you exactly which folder path you're currently sitting in. LS will list out all the files and folders inside that current directory. Need to create a new folder? Just type mkrd to make a directory. And finally, CD allows you to change directories, moving you seamlessly from one folder to the next.
Now, here's a really interesting trade-off when it comes to actually running Python. You basically have two main ways to do it. On one hand, you have the interactive REPL, which stands for Read, Evaluate, Print Loop. This gives you an immediate, instant response, making it absolutely perfect for quick one-line arithmetic checks. But the catch? The code is completely ephemeral. It's lost the second you exit. On the other hand, you have this script file, which ends in .py. This permanently saves your code to your hard drive. You'll definitely want to use script files for writing reusable programs, building real projects, and creating automated pipelines.
So let's look at what a simple script file actually looks like in practice. Notice that very first line? The hashtag creates a comment. Comments are just helpful little notes written by humans for humans. The Python interpreter completely ignores them. Then, below that, we have the print command. See those quotation marks around "Welcome to programming"? Those are absolutely critical. They tell Python, hey, this is a literal text string I want you to display on the screen, not a command you need to execute. Python runs line 2, then moves sequentially right down to run line 3.
But check this out. What happens if we completely drop those quotes? If you type print, open parentheses, 100 minus 45 plus 20, close parentheses, well, Python notices there are no quotes. Because of that, it treats the contents as actual mathematical quantities, calculates the sequence, and will print the final result, which is 75, directly to your screen. It is doing the math for you.
And finally, Section 5, Debugging like a Pro, How to Read Errors Calmly.
Listen, the very first thing we need to do here is normalize failure. Encountering errors is a completely normal, everyday part of software engineering. Every single programmer gets them. There are basically 3 common beginner mistakes that are incredibly easy to make: missing quotes around your literal words, mismatched or unclosed quotes, and accidentally capitalizing built-in Python keywords. Keeping a sharp eye out for these top 3 traps is going to save you a massive amount of headache as you learn.
Now, when Python encounters an error, it prints out what's called a traceback, which is basically just an error report. If you see a traceback pop up that says something like name error, name welcome is not defined, please do not panic. Let's just translate it calmly. It simply means you fell into trap number 1. You forgot your quotation marks. Because there were no quotes, Python looked around for a specific built-in command named welcome, couldn't find one, and throw an error. The fix? Just add your quotes back in. It's really that simple.
Okay, quick fun fact before we wrap up, because it is just mind-blowing to think about what CPython is doing secretly behind the scenes. First, a process called lexing and tokenizing converts your typed characters into language tokens. Second, those tokens form what's called an abstract syntax tree to map out the hierarchy. Third, it compiles that tree down into 16-bit binary bytecode. And finally, an evaluation loop processes each microscopic instruction against your physical CPU. And the crazy part? All of this happens completely invisibly in a fraction of a second.
So, as we wrap up our explainer today, I want to leave you with this thought to really test your mastery. How would you explain this digital kitchen to a friend? Why do computers actually need a language like Python instead of just reading raw English? And more importantly, when you open up your terminal today, what will you write in your very first 3-line recipe? Dive in, practice those commands, write a few print statements, and I will see you in the next explainer.